Today we're going to be solving the major element algorithm. We'll be using Rust actually. So basically, it's supposed to be more of you have an element list of length n, right, or an array list of length n, and the element that occurs the most, that is the major element. The major element is the element that occurs the most, and it must also be longer than half of that list. That is, if the list of if the length of that list is n, right, it must be longer. It must the occurrence of such major elements must be more than n divided by 2. So say the length of the list is 4, then that means the most occurring element, which is the major element in this case, that is the major element, must be greater than 2, right? So in this case now, I've already set up my Rust environment. Actually, it's just a basic algorithm that I'm interested in showing and solving. I've actually increased the size of my screen so it can be easy for you to follow along. So first we'll create a function, which is the major element function. So major element function is going to give out an I32. Reason for this is because in the case where there is no major element in the list that we passed to our function, then we want to return -1, right? We could have, but we're assuming that the elements in the list could actually be big. The value of each element in the list could actually be big. That's why I'm using an I32. Anyway, we're also going to have a public function execute, which is what is going to be called by the function outside. It doesn't return anything. The only thing it does is it's going to print out our function. It's going to print the result of our function. In this case, let's just say result, and that should be equal to major element, right? And we'll pass it list. So let's use something like a vector of 3 2 3. So basically, okay, what is our function going to expect? Let's just still rule out this, right? What is our function going to expect? It's going to expect a list of type vector, right? So it's a vector of u32 integers, and it's also going to expect a low and a high, which is the left and the right of the list that we are passing to it, right? So both of them are going to be of type u32, right? So and it's going to be giving out an I32 value, like we said. So to fulfill our righteousness anyway, let's return -1. That's in a case where in our function we don't find what we are looking for. In a case where we actually don't also find it, that is, if you are passing it an empty list where the left is 0 and the right is 0, or the left and the right are the same length, then you want to also return -1. That is, there is no major elements in this type of list. So I want to say if right is equal to the left. Sorry, that's my JavaScript acting up. Then you want to return -1, right? And so we already know what our function is. Let's just try to call it here. So basically we need a vector that contains, basically let's just say 3 2 and 3 integers, 3 2 and 3, and then we also want to pass it a left. The left is going to start from 0, and the right is going to be 3, because that's the actual length of our list, right? And because this we are going to use it, it's still going to be transferred and others, we'll still make this a borrowed vector, but let's still get there first. So what do we need here? In the next place, we want to be able to return the particular value that is at a particular point of our list, because this is a recursive function, right? So there's supposed to be a tail. There's supposed to be the base that is being returned for the recursive function. So in that case, we say if if the left that is being returned plus 1 is actually equal to the right, then we will return whatever is at that point, at that position of the left. So in this case, to fulfill the righteousness, while we're having any problem, it's expecting a U32. So we'll pass a U, cast it to an I32 because it's actually expecting an I32. Now, because this list has already been transferred, it means we can't use it again. So we'll still actually make it borrowable anyway. So now what we want to do is we want to create the left part, since it's going to be a recursive function, right? So we say let the left element be equal to, we call our major element, right? And then we say, we pass it the list again, and then we're going to say something like major element of passed it the list. Your left this time is still going to remain 0 because this is the left part, and it's going to move towards the left part. I'm going to try to see if I can make a paper recording of what this actually looks like, because I had problem understanding this initially. Anyway, so and the right is going to be let's see how to calculate this. We'll just say something like left, right, plus right minus left divided by 2. So this will be the value of our new right. So say we passed it something that was actually a length of 5, right? Then initially when it comes in, it will be 0, 5. Then the left part after that one, it will be, because this is an unsigned integer, right? Something like U32. So what you'd expect is when we say right minus left, that is 5. That would be 5 in this case, right? Minus 0, that's equal to 5, divided by 2, that's equal to 2.5. Because it's an integer, that is 2. We're not using the float. So what you would expect is 2 plus 0. That will now be the result. So what we'll be passing as the left for the next recursion will be equal to the list, then 0, and then 3 and 2 would be the content. So that would be 0 and then 2, right? Because that's the result of this calculation. So we do the same thing too for the right part of the whatever was given to us. So that's right, lm, that's equal to major element, right? And we pass it list, and in this case the calculation we did there will be what to now be on the right, because that's the one that will now be moving towards the right hand side. So that's just left plus the right minus the left divided by 2, and then we are going to have our right as not changing stuff here until we reach that end. Now as you can see, because we've actually borrowed it, it's already making noise that there's been a move already. So it's been moved already. We didn't even borrow it, I'm sorry, because we've already used it, and vectors do not implement the copy traits. So what we're going to do to solve our problem here is to just make it something that is borrowable. So that's what is being given to us. So this will be borrowed. So every other place that is going to be used is actually going to be a reference to what has been borrowed. Not sure if I said that right. Anyway, so our next point here is to now check for the count, right? So we want to see something more like, so once we are done with this type of iteration, we've gotten the results, we'll now do for the left and the right hand side. So let's do the left count, right, which is the L count. We'll initiate it to 0, right? And it's an integer. We don't need to define what type it is already, since we've already given it. That's the beauty of Rust anyway. And we want to say something like for value in the range, which is in this case from the left to the right. We want to say for I in left to right, if the value at this point is equal to the left element. We're calculating for the left element side now. If it is equal, then we would actually return so we would actually just say L count plus equal to 1, right? And because this is not a U size, let's cast it to a U size. And because this is an I32, that is what was returned by this major element at this point, is an I32, and the value of this list is actually a U32, which is the value inside the vector is actually U32. So we cast this one also to a U32, right? So if that is the case, we will keep adding to it. If it's not the case, you just forget about it. After the loop, all we just say is, hey, if the L count, right, if it is greater than the right minus the left, both of them divided by 2, right? If it is more than half of this, that is, if it has occurred more than half of the size. So in a case where, since for example, this is 5 minus 0, right, and we are saying for it to be a major element, it has to have occurred for more than 2 times, which would, for example, might be 3 times, 4 times, 5 times, right? But not more than the length of the list, obviously. So if the count at the left is more than n over 2, which makes it a major element, then we can actually return that particular element. So in this case, that will be the left element, right? And we just repeat the same thing for the right hand side. So let R count go. My fonts are usually not this big. I'm just doing this for the recording. I need to reduce it back later. So left to right, and you want to say if the list I as U size also, if it is equal to the right element as U32, then you say R count plus equal to 1, right? So we've already solved that one, and then you want to say if R count is greater than the right minus the left. Basically what we just said in that, what we just did before now, then we just return the left, then we just return the right, just return the right element, and basically this is it. So let's test if our function actually works, and if it doesn't, then we debug and see where it's actually not working. So let's cargo run. So first, it's expecting the reference, and we are passing it the actual vector. So let's do this, right? And in this case, this is telling us that you cannot assign to, so this is supposed to be a mutable value. So by default, variables that you declare in Rust are actually immutable. So let's do that, and if we say cargo run for this particular value that we are testing in this case, we can see that it's actually returning the major element in this case, which is 3. So this is what is returned, right? If we try to test it, let's say we remove 3, and then now there is no major element in this list, and we say something like let's run it again. You see that our result will return -1. So dear friends, that's basically how to calculate how to run the algorithm for major element using divide and conquer method in Rust. Thank you very much. This feels fun.